Hello, my name is Maria Miller from mathmammoth.com. In this lesson we're going to study angles in a triangle. And there's a very simple relationship between the angles in a triangle, and that is that all three angles in a triangle add up to 180 degrees. The symbols are alpha, beta and gamma. They are the first three letters of the Greek alphabet, and they are often used to denote angles. And I'm going to actually prove this principle to you in the end of the lesson. Now let's first though use it. For example, here I have a triangle with one unknown angle. These two angles are known and this is not known, so let's use this principle to find what x is. Okay, if this and this and this add up to 180, then all you need to do is subtract from 180 this, and then you get x, right? So you would get 180 minus 70, which is 110, and then take away 37, which would be 73. But let's also write an equation, and the equation would go, you add these three equals 180. X plus 37 plus 70 equals 180. And usually, solving an equation like this, we first add these two. It simplifies this side. So we get x plus 107 equals 180. And now lastly we subtract from both sides this number, as you know. So we get x equals 180 minus 107, which is 73 degrees. This here is an isosceles triangle. Now what did that mean? It means that these two sides here are congruent. They are of equal length. I mark it with this little mark here on these sides that are congruent. But there's something else special about isosceles triangles. Not only are these two sides equal, but there's also two congruent angles in it. They're called the base angles. This angle is actually equal to that one. And now we can use this principle to solve this unknown angle. Because x and 110 total 180 degrees. If you're solving it using mental math, then we subtract first 110 from 180. We get 70 degrees. These two angles together are 70 degrees, and so one of them is 35 degrees, or half of 70. If we write an equation, we have x plus 110 equals 180 degrees. Here I simplify. I add x and x to get 2x. Now, I subtract 110, leaving 2x alone on this side. And over here, I subtract and get 70. And then I divide both sides by 2, so we get the 35 degrees. Here I have an equilateral triangle. That means that all of its sides are congruent, or equal. It comes from the words equal, and then lateral referring to sides. And this is how it is marked, with these little blue marks, that each side is congruent. But there's something else special about it too, because all three angles are congruent too. In other words, if this is alpha, this is also alpha, it's congruent, and this is also alpha. And so now we can use this principle to solve how much alpha is. This plus this equals 180. So alpha must equal 60 degrees, right? This is 60 degrees, so how much is x then? X and alpha together they're supplementary angles, so together they add up to 180 degrees, right? If here's 60, here must be 120. Let's go on to this one where we have alpha as one angle and 2 alpha as another angle. And I'm just gonna write an equation again, add those three. That's alpha and 2 alpha and 108. And the total is of course again 180 degrees. Now I'm going to add alpha and 2 alpha together. That makes 3 alpha. And then, what's next? We subtract 108 from both sides, which leaves 3 alpha alone. And then over here on this side, 180 minus 108 is 72. And lastly, divide both sides by 3. And so we get alpha equals 24 degrees. This is 24, and this of course would be 48 degrees. Now, draw an isosceles triangle with 40-degree base angles and 20-centimeter legs. Comparing to this one, the base angles are these two. This is called the top angle, and the legs are these two sides that are congruent. So if I sketch it here, I have something where both of these are 20 centimeters, and then both of these are 40 degrees. So where would I start if I want to draw this? I don't know how long this side is, so I cannot start by drawing it, obviously. I could draw a 40-degree angle, one of them, but like I said, I cannot know how long to continue this one side. So it looks like maybe I would want to start here, okay, at the top. I can figure out the top angle because 40 plus 40 is 80. And so this must be 100 degrees to make 180. So if I start here, and I can draw the angle, and then I can measure these 20 centimeter sides, then I will find this point where it is and that point. Okay, so let's try that. I'll start here at the top. And just draw one side. That's 20 now. Draw the angle, 100 degrees. Okay, it goes that direction. And then I measure the other 20 centimeter side. Okay, over there, now draw in the third side. There, the third side is a little over 30 centimeters. And so these should be now 40 degrees automatically. Lastly, like I promised you, is the proof of this principle. And for that, we need one more principle, which is corresponding angles. If you have two lines that are parallel, these black lines here, or this and this, are parallel lines, and then a third line that intersects them both, then you have lots of angles formed, like this and this would be vertical angles, this and this would also be vertical angles. But also, this angle is congruent to this angle here. These two are called the corresponding angles. They are like in a corresponding spot or corresponding corner or in the same looking position, so to speak. So this is the principle we're going to use in the proof. Here is a generic triangle. Imagine it's basically representing any triangle there. It has three angles, alpha, beta, and gamma. And we draw a parallel line here, parallel to the base side of the triangle. And then something interesting happens. Here, this beta is also here, being vertical angles. Okay, there's this line and this line that intersect, so these are vertical angles. They are congruent. And then this alpha angle is somewhere else too. Can you see where? There's going to be a corresponding angle. Okay, because these two are parallel and this intersects them both. So alpha is also here. And then gamma is also somewhere else. This and this are parallel. This line intersects them both. So gamma is also here. And now you can see that alpha, beta, and gamma together here form a straight angle. Because here's a line, okay? They together form 180 degrees. So that is the proof. It's fairly simple, actually. Okay, and now we are all done with the lesson.